1 begins with integers. The real number line gives us the idea of integers. We will see that the origin is marked here at the 0 point. And then, as we've discussed before, as the numbers go to the right, they get larger, and those are the positive numbers. And as you go to the left of the origin, you'll find the negative numbers. And again, as we move left on the number line, numbers get smaller. To the right, numbers get larger. So if we are looking at the number line here, the scale marks are equally spaced and represent all integers. An integer is either negative, 0, or positive. So if we were going to graph the numbers 1/2 and the decimal negative 2.3 on a number line, we would do so in the following way. 1/2 is positive, so we want to look at the right of the origin, 0, and then we know that 1/2 comes between 0 and 1, so we can graph 1/2 as shown here in blue. Now the negative 2.3 we know is left of the origin because it is a negative number, and we know that as numbers go to the left, we are counting, our traditional counting is bigger, however those numbers are smaller. And so negative 2.3 is going to land between negative 2 and negative 3. So you will see that that is marked with the red point. Now, to graph negative 4 and negative 5 on a number line, it says graph those first. Those have been graphed, and it says then write two inequalities that compare the two numbers. So what I could write is, I could write them, and the first two I'm going to show you, I'm going to write simply the way that you see them on the number line. If I write negative 5 and then negative 4, because I'm reading left to right. Then you can use the trick of the less than sign looking like an L. So negative 4 is less than negative 5 is less than negative 4. If I'm doing it the other way, I'm going to say that negative 4, and negative 4 is to the right of negative 5, so that means it is greater than. So negative 4 is greater than negative 5. Okay? Again, I highly recommend to read it and write it in the way that you're used to reading in a textbook from left to right, and it will help you understand how to write it. Now, if you have to find it on a number line, it's going to be slightly different. So ordering real numbers, we have, it asks us to write it in increasing number, so order. We're going to start with the smallest and get to the largest. One thing that I want to point out is, the first thing that I would do is I would separate the negatives from the positives. So in this case, I have, and I'm going to make the negatives red, I have a negative 2 and I have a negative 3/2. So I know those are going to be to the left of the origin. I also have the origin, which is a 0. Now, in the black, to use a term that businesses use, I have a 4, a 1.5, and a 1/2. So that will help me at least be on the correct location from the origin. So as we do that, we're going to look at our negative numbers first. Negative 2 is marked there. Negative 3/2, and if you need to, you can change that into a mixed number, which that would equal negative 1 and 1/2. That's going to come between 1 and 2. Then we also have 0, which is marked, and you can see and so on with the other ones in increasing order. Now, I will not ask you to draw a number line all the time. I will ask you to write them in order. So if a number line is easier to visualize it, otherwise if you do like I said and separate the negatives from the positive, it'll make it a little bit easier. So in example 4, they ask us to compare real numbers. So this time we have to understand the meaning. You're going to notice here that in our graph, we have some negative numbers, and we also have some positive numbers. So it says the table at the right shows the low temperatures recorded in Nome, Alaska, each day for 5 days in December. Which low temperature reading was the coldest. So the coldest is going to mean that we need to find the number that is going to be the lowest on a number line or a thermometer, if that helps you. So my lowest temperature or my coldest temperature is going to be, for the answer for letter A, would be negative 11 degrees, and that's in Fahrenheit. And let's see, and that was on the date of December 19th. Okay, which dates had low temperatures of above 10 degrees Fahrenheit? So we're on the right side of the origin. So we look at our positive ones that I marked in black there. And the only one that is a larger number than 10 would be December 20th, which was the 16 degree. So number 10 would be the 16 degrees Fahrenheit, and that is on the 20th. And then my last one, which dates had low temperatures below negative 5 degrees? So negative 5, we're going to look at the left side of the origin, and we're going to look at ones that are going to be further left. That makes them even colder. So for this one, I'm going to cheat a little here, and I'm going to say the negative 11 degree one and the negative 10 degree one. Save me a little bit with writing with the pen. So for goal 2, we're going to find opposites and absolute values. And there's a simple way to remember this. However, they're always presented at the same time, and sometimes they get confused. So I'm going to talk about, I'll do it the same as it's in the book, opposites. Now you're used to opposites. The opposite of cold is hot. The opposite of up is down. The opposite of right is left. And so it just means that you're going to go in the opposite direction. And you're going to jump this. We're going to just jump in the opposite direction, the same units or the same jumps from the origin. So if it asks you the number, it tells you the number negative 3 and 3 are opposites because they're both 3 units from the origin. So if it asks you what is the opposite of 5, 5 is 5 jumps or 5 units from the origin. So I would simply go for the opposite. I'm going to go 5 to the left. So the opposite of 5 is negative 5. Now absolute value is different, and sometimes when we get used to when we look at the opposites, we mix the two of these up. Absolute value is just asking you what is the distance from the origin. Okay? You can't jump negatively. So it's going to turn out that when you find an absolute value, it's always going to be a positive. Okay? It's how many places, how many units there is between the origin and that number. It doesn't matter if you're going left or right. Now, the symbol for absolute value are the bars around the number. So in the example here, we're asking the absolute value of 3, the absolute value of 0, or the absolute value of negative 3. Now, in simplest terms, absolute value, because you can't jump negatively, is always going to change or keep a number positive. Absolute value is always positive. That sometimes gets confused when you're working with absolute value and opposites on the same time. So we're going to do just a couple of them in example 6. So it says evaluate the expression. Now, absolute value symbols, sorry about that, absolute value symbols are very similar to parentheses. They should be counted the same as far as order of operation. So 2.3, but we have absolute value. So how far is that from the origin? It's still 2.3. Negative 1/2, how far is that from the origin? It's going to the left, but in absolute value that doesn't matter. It's still just 1/2 away from the origin, 1/2 step. Very sloppy, but it's still 1/2 step. Now be careful with letter C. Letter C is asking for the opposite or negative of the absolute value of negative 8. So I'm going to have the negative The absolute value of negative 8 is going to be 8. But because of the negative sign outside of the absolute value, or outside of the parentheses if you want to say, the answer is going to be negative 8. It was the opposite of the absolute value of negative 8. Absolute value of negative 8 is 8, but outside of the absolute values is a negative. So we're going to try to apply this then when we are working with solving an equation. So let's use mental math to solve the equation. Well, the absolute value of x, well, that's going to change anything that's inside there into a positive. So x could be positive to start out with, but x could also be negative 7. So the answer for letter A would be 7 and negative 7. Both of those work. The absolute value of x is going to equal negative 5. There is no solution to that because absolute value can never be a negative. So this one would have no solution. We still have a couple more examples here. We're going to talk a little bit about velocity, and you'll be talking about velocity when you go to Swiss Valley later this month. Sorry. Velocity indicates both speed and direction. Up is positive and down is negative. The speed of an object is the absolute value of its velocity. So the space shuttle elevators. A space shuttle launch pad elevator drops at a rate of 10 feet per second. What are its velocity and speed? So velocity, we want to make sure that velocity is showing that it is going down. It's dropping. So we're going to make sure that we label that as a negative. It's dropping. However, speed always has to be positive. Speed of an object is always the absolute value. So speed then would be the absolute value of negative 10, or it's moving at 10 feet per second. The velocity told us it was moving downwards. The speed tells us how the rate at which it's moving, at 10 feet per second. So in mathematics, to prove that a statement is true, you need to show that it is true for all examples. To prove that a statement is false, you need to show that it is not true for only one example, called a counterexample. So decide whether the statement is true or false. If it's false, give the counterexample. So letter A says the opposite of a number is always negative. That's going to be false. If the number starts out negative, the opposite, again, is going in the opposite direction, the same amount of units. So if my number started out negative, the opposite of it would be positive. The absolute value of a number is never negative. That would be true. We said it's slightly different. We said absolute value is always positive. They tried to confuse you a little bit there with the words that they're using. The next one, the expression negative A is never positive. That never is a pretty big word. That is going to be false, and I'm going to show you an example of that. So for letter C, I'm going to prove the counterexample. If A started out to be a negative 2, okay, then negative A would be a negative, whoops, sorry about that. Let me go back to that. A negative 2. So when we see a negative, that's also, we could say, the opposite, using our new vocabulary, the opposite of negative 2, or a negative with another negative changes that to a positive. So that answer is that it is positive. Therefore, I had one example proving that it was false. The expression is never positive. Letter D, the expression in negative A is sometimes greater than A. Well, that's actually true. Pressing too hard, I'm changing that. Whoa, that's quite the T. That's actually true. Let's try, let's do A equals, let's do it as a negative 8. Then negative A would be equal to, the same as up above, negative 8. And negative 8 is equal to equal to 8. And the beginning of that said negative A is sometimes greater than A. We said that A is negative 8. So negative 8 is 8, and A is negative 8. So 8 is greater than a negative 8. Our beginning variable was A equals negative 8. And that's how we proved that one wrong. That concludes all of the vocab and intro to chapter 2 on integers. I'm going to have to do that on my computer.